isomers, and the phenomena is known as isomerism. So I think it's clear to both of you the definition. Now I'm going to divide this isomerism into two parts. Here the isomerism we are going to divide is its two part. One is your structural isomers or a structural isomerism, and it is further divided into four parts. It is further divided into four parts. The first one is your solvate or hydrate isomerism. Solvate or hydrate structural isomerism. Okay. The second one is your ionization isomerism. I'm not going to write again and again isomerism. That is understood. Ionization, structural isomerism or ionization isomers. Then comes your coordinate isomerism. And then comes your linkage isomerism. So basically, we have two types of isomerism. The first one is a structural, and the second one is your stereoisomerism. A stereoisomerism or a stereoisomers, we can say. Now, this stereoisomers is also divided into two parts. The first one is geometrical isomerism. You have heard of this in class 11th organic chemistry, and the second one is optical isomerism. So you can see a structural isomerism is divided into four parts: solvate or hydrate isomerism, ionization isomerism, coordinate isomerism, linkage isomerism, and this stereoisomerism divided into two parts: geometrical and optical. So today we are going to complete this. Please do write it. We will write the definition as well as the example. Let me know when you are done with this. Let me know when you are done with this. Are you done, Austin? Mom, you are not audible.
Yes.
Mom, you are also done.
Yes, sir.
Okay. Now see. Now we are going to take one by one the structural isomers. So I'm going to start this structural. Very easy it is. Structural isomerism. Always remember that in a complex compound, if it is given, its ligand will be constant. That means coordination number will be constant. We will do question on coordination number as well today. So the first one is I'm going to take solvent isomerism. Solvent isomerism. So first I'm going to explain this. You can see basically if you have a compound, complex compound H2O whole 6 and there is a counter ion Cl3. So what you need to do, very simple it is. The coordination number, can anyone tell me what is the coordination number of this complex compound? Coordination number, if you remember, what is coordination number? Total number of coordinate bond CB. That means coordinate bond between central metal atom and ligand. Are you getting my point? So first recognize H2O is a bidentate, polydentate or unidentate, monodentate. What type of ligand it is? Omam, Austin, H2O is what type of ligand? One H2O molecule has how many donating site? Only one. So what will be the coordination number here? 6, yes or no?
Yes.
Now you can see that 6 is the coordination number. Now, what is solvent isomerism? When there will be exchange or you are going to decrease basically H2O whole 6. Now what I'm going to do, since I told you the ligands, the coordination number will be constant. Now the coordination number is constant and there will be exchange between water molecule and this. This both have same molecular formula you can see, but different arrangement of the ligands. And that's why they are known as solvent isomerism. Is that clear? You just need to exchange it between water. This solvent isomerism is especially for water. There will be exchange between water and the counter and whatever it is. Okay. So first point I'm going to write. This is also known as hydrate isomers. Hydrate isomerism or isomers. Now, what is the definition? How we can explain? Isomers is different in a number of molecules, is in number of molecules as ligand, as ligands in number of, oh, wait a minute, in number of water molecules, basically, water molecules and free solvent molecules in crystal lattice. So basically, number of water molecule will be different. So how it is? So there will be exchange between these two. Simple. You can write another one as well if you want to. CrH2O whole 4. Now, since the coordination number is 6, the coordination number should be 6. Now I took 2Cl inside. Now it becomes 2H2O, you can write, or yeah, something like this. Okay. Have you got it, both of you? Mom, sometimes you are not audible. Please let me know when you are done with this, or if you have any doubt. Both of you done with this.
Done.
Are you done with this, Mom?
Yes, sir. Done.
Very good. Now see, the next isomerism I'm going to take is coordinate isomerism. So coordinate isomerism. What is coordinate isomerism? I'm going to explain with the help of example. This coordinate isomerism is possible only in this type of compound, this type of complex, where you will get complex like CrNH3 whole 6, and there will be like this. These are one complex compound. Now, what will happen? The central atom, natal atom, they will coordinate with each other and exchange their ligands, exchange their ligand. So this type of isomerism is known as coordinate isomerism. Is that clear? This is a single complex, this is a single complex. Both have same chemical formula. So we can write this type of isomerism is due to exchange of ligands in between cationic and anionic coordination sphere. Coordination sphere. So basically, as I told you, in inorganic compound, if you have a compound like this will be cation, this will be anion. So as you can see, there is two complex compound given in one as a single, whole as a single. This will be cation and this will be anion. So this type of isomerism is due to the exchange of ligands in between cationic and anionic coordination compounds. So this is, let's say, cation and this is anion. So there will be force of attraction between them and they become one. Now, when they are going to exchange their ligands, then they form coordinate isomerism. Is that clear to both of you?
Yes, sir.
Please do write it. Let me know when you are done with this.
Done, sir.
Linkage isomerism. Linkage isomerism, that means this type of isomerism arises due to presence of ambidentate ligand. Ambidentate ligand. Only link changes. That means you know that ambidentate ligand is the one which is having two donor side, but it can use only one at a time. Ambidentate ligand like NO2 minus, CN minus, and SCN minus. Now you can see that, for example, we can take CONH3, whole 5 NO2 is there, and Cl2 is there. Now, what I'm going to write? So write CONH3 whole 5 NO2. That means here the donor is nitrogen. Now what I'm going to write? ONO. Now here the donor is your oxygen. Are you getting my point?
Yes, sir.
Yes or no? So write it please. In the same way, there can be Cn minus and SCN minus as well. Let me know when you are done with this. Let me know when you're done with this. Write it little faster. Very slow. Both of you are going. Uma,
Yeah, 10 cent.
The next one is your ionization isomerism. And ionization isomerism or isomers is basically same as water. There will be exchange of ions, but not between water. If exchange of ions like exchange between the counter ion and water will take place, that is especially for hydrate or solvent isomerism. Other than that, that is called ionization isomerism. So I'm going to write a point. Please do write with me. The type of isomerism which is due to the exchange of groups or ion between coordination sphere and ionization sphere that is called your ionization sphere, ionization isomerism. For example, we can take NH3 whole 4 Br2 and SO4 is there. Now you can see this SO4 is flexidentate ligand. Flexidentate ligand, that means according to the requirement, it can change its denticity. So here it is total coordination number is equal to 6. Now it will exchange with bromine. It will exchange with bromine and NH3 whole 4 SO4 will be there and Br2 comes outside. Coordination number will be as it is because SO4 here is acting as didentate because SO4 exists in -2. Everyone knows that this exists in -2, right? So O negative is there. So there are two donor site. Is that clear?
Yes, okay.
Please do write it. Hydrate done. This is also done. Okay. Tell me, is this hydrate isomerism? If chromium is there, now just write it and let me know, then talk about this.
Damn, sir.
Oh, very good. So these are all completed. Now what we are going to do, there was a question that I wanted to ask, solvent isomerism. So what if I'm going to write it like this, Cr H2O whole 3 Cl3 of this as an isomer, will it be isomer or not? Will it be hydrate or solvent isomers, yes or no? Both of you. Yes or no?
Yes.
No, it won't be. There must be something. At least one Cl should be there. Otherwise, it will be water of crystallization, something like that. You cannot say this is hydrate isomerism. So the exchange that is taking place, there must be at least one unit of that like this. Are you getting my point? Always remember this. Very important point it is. Okay. Can we move to the next part?
Yes.
Okay. Now I'm going to write the next part, stereoisomerism. So what is a stereoisomerism? In this only the spatial arrangement will take place. First, I'm going to define it right with me. They have same molecular formula, same constitution, they differ. They differ only with respect to only with respect to the spatial orientation of ligands, a spatial orientation of ligands in a space around central metal or around the metal ion, around the metal ion. So basically, same chemical formula, constitution, everything will be same. Only the spatial arrangement or spatial orientation of ligands will be there around central metal ion. Okay, is that clear? Now these are divided into two parts, as I told you, geometrical and optical. One by one, we are going to pick it up. Please do write it, then we will talk about this. Do you know how to calculate bond order, right? Sorry, hybridization. Yes or no? Not audible, both of you.
Yes.
Let me know when you are done with this. Stereoisomerism is of two types, geometrical isomerism and optical isomerism. Let me know when you're done with this. Let me know when you're done with this. Mom, are you done with this?
Yes, sir.
Okay. So before starting this, I would like to give you a question, this question, and let me know the coordination number of each. You are not going to do the IUPSC. Already you have done. You are going to tell me the coordination number of each of the following. Please tell me. You can look at the compound and tell me the coordination number of that easily. Please do it. Any answer? Austin, Humam. Very good. You should not take this much time. You can say this is monodentate. So coordination number will be 6. Monodentate, monodentate, monodentate. Carbon cannot donate. So you can see 1, 2, and 2, 4. So the coordination number for 2 is 4. Monodentate it is 6 coordination number. 4, 5, 6. 6 coordination number. 6 coordination number. 4 coordination number. 6 coordination number. This is didentate. So 2 into 3, that is 6 coordination number. CO is monodentate. This is 4 coordination number. Very easy. Right, Austin Humamuddin?
Yes.
Can I change the slide? Sir, can you explain to 2, 2, 2, 2, 2C? PT is there, NH3, whole twice, Cl, NH2, CH3. Now, this is the scenario, right? Now, what I told you, this is monodentate, so 2 coordination number. Due to this, chlorine is also monodentate, so due to this 1, and NH2CH3 is also monodentate, so that's why coordination number will be 4. Now you have confusion only with this one, so you can see carbon is making 3 bond with hydrogen and 1 bond with nitrogen, right? And nitrogen is making 2 bond with hydrogen. Nitrogen, since total bond making 3, that means 1 lone pair will be there, so it can donate to form a coordinate bond, right, Austin?
Yes.
Isn't it easy? Just let me know when you are done with this. Can I change the slide?
Yes. Yes.
Okay, before starting, first of all, we will discuss about geometrical isomerism. So before starting that, I'm going to write here coordination number. Coordination number. And here I'm going to write hybridization. And here I'm going to write geometry. You know, hybridization, you have studied in class 11th. That hybridization, if you know the structure, that is equal to sigma bond plus lone pair. But here the hybridization is very easy. You know why? Because all will be the sigma bond. Most cases, apart from carbonyl, that we will see what it is, sigma bond will be formed because it is forming coordinate bond, so it will be sigma bond. So if coordination number is 4, the hybridization can be sp3 and geometry is tetrahedral. You have studied about this. If coordination number, that means the sum we are talking about is 4, then the hybridization can be dsp2 and the geometry is a square planar. A square planar. And if it is 5, then it is sp3d and the geometry will be tbp, that is trigonal bipyramidal. That is trigonal bipyramidal. And if it is 6, the geometry is sp3d2 and it is octahedral. And if it is 6, then it is d2sp3 and the geometry is octahedral. We need to focus in our syllabus only these two, and these two are there. And for geometry, basically geometrical isomerism, these two are more important. Okay, this will be also, but not that much. Are you getting my point? So you will come to know about this. Coordination number 4, why the hybridization is sp3. Coordination number 4, why the hybridization is a tsp2. 6, sp3d2, d2sp3, why it is so, and why the geometry is different. So the geometry basically totally depends upon the hybridization. Since hybridization is different, that's why they have different geometry. But here the hybridization are different, but the geometry is same. That depends upon the group that is attached. So first you are going to write this, then we will talk about geometrical isomerism. That is, you have heard of this cis and trans, right?
Yes.
Yes or no?
Yes.
Yes, cis and trans, you have heard of this. Now let me know when you're done with this. Both of you done with this.
Done, sir.
Okay. Now let's start our geometrical isomerism. So you know that geometrical isomerism, that means we are talking about cis or trans isomers. Cis or trans isomers generally. Now, as I told you, we are going to study only the coordinates number which is in our syllabus. And you know that in our syllabus, the first one was coordination number is equal to 4. Now, due to this, you have two types of geometry. You have two types of geometry. The first one was square planar. I'm going to take this as square planar. And here, the second one is your tetrahedral, right? With coordination number 4, we got two types of geometry. Here it is tetrahedral and a square planar, right? So first of all, what you need to take care is that GI does not show in tetrahedral, does not show GI. If it is tetrahedral sp3 hybridization, then it will not show GI. You know why? Because let's say there is a metal M and there is like this A, B, C, D, something like this. We can say A, B, C, and let's say this is D, or A, B, you can take. Let's take this is A, this is B for geometrical and optical, A and B. Now, what I want to tell you is that if you are going to measure the distance between these two, and if you are going to measure the distance between these two, L1, let's say L1 and L2. L1 will be equal to L2, and this is the opposite condition to not show. Basically, this is not the condition to show GI. There must be the distance should not be equal. Since they are equal, that's why since this is tetrahedral, so that's why basically it will not show GI. Are you getting my point? Let me draw it in a better way. Let me draw it. Or wait a minute. I'm going to explain this. First, a square planar. It will be very easy to understand. See, for a square planar, you know, a square planar, the structure will be like this: A, and I'm going to take A, and here it is B, and here it is B. Now we can write A, opposite side, same group, you know, this will be trans. Now, if you are going to see the distance, this is L1, and if you are going to see the distance L2, or since I took the distance between AA, I'm going to take from AA from here. This is your L2 and that is your L1. And if the distance you will measure, it will not be equal to L2. That's why it will show your geometrical. This will be your cis and this will be your trans. Now, but when we are going to talk about this, then we are going to talk about this M, and let's say this is your A and this is your B, and then this is your B, and then this is your A. Now, if you are going to measure this distance, it is L1. Now, what I'm going to do, M, A is there, then comes your B, then comes your A, then comes your B. Now, if you are going to measure the distance between these two, A and AL2, they are equal. L1 is equal to L2. That's why the distance should not be equal if you are going to change the position. And since the distance is equal, that's why tetrahedral does not show geometrical isomerism. Are you getting my point? Now, how will you able to recognize whether which one is tetrahedral or sp3 hybridized? So in VVT, you will come to know. This is your sp3, this is your dsp2. Write it. Now let me know when you are done with this.
I'm sorry.
Austin, you are also done.
Yes.
Okay, write a point with me. 4 coordinated. That means 4 coordination number. Complex with tetrahedral geometry. With tetrahedral geometry. Do not exhibit. Write with me. Whatever I explained, that's I'm writing. Since trans isomerism. Since trans isomerism. That means geometrical isomerism. Geometrical isomerism. Because a relative position of ligands because relative position of ligands remain same for each other. That's why. Next point we can write. It is exhibited by 4 coordinated complex with a square planar geometry. With a square planar geometry. Isomerism in a square planar oh, wait a minute. With a square planar geometry. There are only few possible cases which shows geometrical isomers in a square planar. Write it. I will write the cases, then we will discuss about that. Planar complex. In the last point we can write. Such as MA2B2, MA2BC, MABCD, and MAB twice. This is your didentate. All others are monodentate. Let me know when you are done with this. Let me know when you are done with this. Are you done with this?
Done, sir.
Very good. Now see, this is a very important point. Now we are only talking about coordination number equals to 4, and this is for a square planar because coordination number 4 tetrahedral does not show GI. Now this point is very important. GI, that means geometrical isomerism. In coordination number 4, how will you come to know whether which coordination number with 4? It is not necessary that all the compound will show geometrical isomerism. So how you will recognize it? So you are going to make a make pair of ligands. Make pair of ligands. If two or more than two different sets are possible, then it will show GI. I will explain with the help of example. First write it, then I will show you. Both of you done up to this. Mom.
Yes, sir. Done.
Okay, now we are going to start this. Now see. Geometrical, write the topic with me. Geometrical isomers. With coordination number equals to 4. That means this is, since we are talking about geometrical isomerism, it is understood that it is a square planar complex. Now, first case that I'm going to take is complex with general formula. General formula Ma2B2. Four ligands are there. That means A and B, where A and B both are monodentate. Are you getting my point? Monodentate. Now, I'm going to write here complex with general formula and Ma2B2 can have cis and trans, because I know that and I will prove it. Cis and trans isomers. Now, whenever this type of question will come, what you need to do, you can see here that it is Na2B2. This is the complex compound. So what you are going to do, there are four ligands. So you are going to make pair of them. AA can I write, and this is your BB. And here it is AB, I can write, interchange it, and it will be AB. So you can see there are two types of different pairs, and this red point that I had written is very important. As I told you, I did a star mark here. So you can see make pair of ligands if two or more than two are different sets. If you are getting two or more than two different sets, if there is possibility of that, then it will show GI. And here you can easily see that we got two pairs. That means it will show GI. If you will not get two, if you will get only one pair of set, then you will not be able to get GI. Like in case of MA4, how you are going to differentiate A comma A comma A and AA. So this will not show GI. Are you getting my point, Humam and Austin? Please do
Yes.
respond. You're not audible, Humam. I don't know why the mic is not working or the. So this is your trans and this is your cis. We do it like this. Let me know when you are done with this. Let me know when you are done with this. Are you done with this, Humam, Austin?
Yes, sir.
Okay, I'm going to give you a complex example of this. That is PT NH3 whole twice Cl2. So this is, we can write NH3 NH3, and here we can write Cl and Cl. So this is your cisplatin known as, and it used in cancer therapy. PT NH3 NH3, and this is your chlorine chlorine. This is your transform of that, and this is your cis. Very simple it is. Write it. Let me know when you are done with this. Let me know when you are done with this. Mom, Austin. Very good. Mom, what? The next case I'm going to take for this, complexes with general formula. Ma2BC can have cis and trans isomers. I can show you this easily. If you have Ma2Bc, that means I can write AA BC one pair and another I can write AB and AC two pair. That's why it will show GI minimum two pair. So GI. With respect to one of the group, we will say this is your Ma, C, and this is your D. I'm going B. It is not D. What I'm going to do with respect to A, I'm going to say it is trans. And with respect to A, I'm going to say it is cis. Very simple it is. So write it and let me know when you are done with this. Let me know when you are done with this.